All right, hello everyone. So let's go ahead and take a look at the experimental details and the process for the group 1 ions experiment, so experiment 9. So what we have set up here is a station for the group 1 knowns, which is on the left of the screen, and then a station for the unknowns, which is over here on the right. All right, so we're going to be simultaneously analyzing the group 1 knowns, and the group 1 known solution contains silver and mercury and lead, so all three ions are present in that solution. The unknown will contain one or two or three of those particular ions. So we don't know what that is, but by running these in parallel, we can determine what is present in unknown number 5. And so I've just randomly picked unknown number 5 to kind of go through this process. All right. So the procedure starts by having you transfer 30 drops of the known solution into a dry test tube. So I have 30 drops of the known solution here in the test tube on the left, and then another 30 drops of the unknown number 5 here in the test tube on the right. Okay, and so we're going to be running these in parallel, even though the procedure kind of goes through with one test tube first, but we're going to run them both kind of at the same time. All right, so the next thing we're going to do is take some 6 molar hydrochloric acid, and we're going to add in 5 drops of 6 molar hydrochloric acid into the solution. Okay, so here we go. I've got 1, 2, 3, 4, 5. Okay. So notice very quickly we have a very bright white precipitate. So just by adding in the hydrochloric acid, the group 1 knowns, we have this very white precipitate that is formed right away. All right, and so that precipitate being formed tells us automatically that there has to be one of those 3 ions present, because remember, if we think back to solubility rules, chloride compounds are usually soluble unless we're talking about silver or mercury or lead. So this goes all the way back to solubility rules in the first semester of the course. Okay, so we know that there is either silver, mercury, or lead present in these. And of course, with this one, the known, we know that it is all 3. Now, if we do the same thing with unknown number 5, right? So again, we're going to take and put 1, 2, 3, 4, 5 drops of our 6 molar hydrochloric acid in there. All right, and again, big cloudy white precipitate that's formed. So again, we know that we have 1 or 2 or possibly all 3 of those ions present in this particular solution. Okay. Then we're going to take these 2 test tubes and we're going to place them in the centrifuge. Okay. So I'll open up the centrifuge here. I'm going to put the group 1 known test tube in channel number 1. And actually, I'm going to go ahead and label on here K, just so I know that this is my known solution. All right. So that's going to go in channel number 1 here. I've already carefully selected these test tubes so they're matched. All right, and so they're about the same size. They have roughly the same volumes in them. I ended up using 30 drops of both the known and unknown in their separate test tubes. All right, so we've got about the same volumes in each, same size test tubes. So here's my unknown, all right, and that's going to go immediately across from the other test tube. So I'm not sure if we can see this in the video, but I've used numbers 1 and 4 in here, so those 2 are directly across from each other. All right, so then I can take this, close the centrifuge door, and I'm going to basically turn on the centrifuge. All right, and I'm going to let this centrifuge go for a certain period of time. All right, so while that spins up, I'm going to go ahead and pause the video, and then we'll come back after the centrifuging is done. Okay, so I went ahead and finished centrifuging, let the centrifuge spin down, and now I'm ready to pull the test tubes out of the centrifuge. So when we pull these out, if you take a look at the solution, notice that that solid, and I'm going to try to turn it around here so we can see on the video, notice the solid is all kind of collected against the one side of the test tube, all right? So we're going to check to see if we have precipitation of all of these solids present. We're going to re-add one more drop of hydrochloric acid, the 6 molar hydrochloric acid, to the known. I'll kind of give it a little bit of a shake to kind of promote any extra chloride salts to come crashing out of solution. All right, doesn't look like much reprecipitated, but that's okay. It's worth trying to recover as much as possible. It makes the test pretty clear then down the road. So that was my known precipitate. So that's going to go back into channel number 1. The unknown, all right, so notice we have that same kind of crust of solid there at the bottom. It's actually kind of sliding around a little bit. That's kind of fun. All right, so I'm going to add one more drop of hydrochloric acid in here. All right, kind of take a look. Yeah, it doesn't look like really much of anything else is precipitating, but I'll go ahead and give it a shake, and we'll go ahead and re-centrifuge this again. And once we go through that second recentrifuging process, then we'll go ahead and basically collect the solids. Okay, so I'll put this back in to number 4. So unknown is number 4. Close the lid, start it all up, and we'll be back then when that is done. Okay, so we've recentrifuged, so that's complete. And I also tested to see if we had any more precipitate form, and no more formed. So we're ready to kind of proceed on to the next step in part 1 of the procedure. So I have my known test tube, and again the precipitate's kind of collected up on the side. We know for the known solution this should have silver chloride, lead 2 chloride, and mercury 1 chloride in here. All right, and so we're going to basically take and decant or pour off the liquid into my waste jar here. Okay, and so I'm going to do that very, very carefully such that the solid stays put in the test tube. All right, so the solid stays behind in the test tube, and then the liquid goes over here to the waste. And I'm just going to go ahead and set that down in here. I'll do the same thing for the unknown. All right, so very carefully, I'm going to pour the liquid off. Here we go. All right, and we'll place that over here next to the unknown funnel. All right, so next we're going to have a small beaker with some hot water. We already set that up on the hot plate, and it's kind of doing its thing there and all nice and warm. So then we're going to need to set up a gravity filtration apparatus. So to set up a gravity filtration apparatus, we did this last semester, but we'll take our piece of filter paper, we'll fold it in half again to make a little snow cone here. All right, so we have our little snow cone, and then we can open that up, put that here in the funnel. I'm going to move my known out of the way, and then just kind of give this a light little squirt with some water for that to stay put. Okay, so my filter paper is staying put. I'm going to let this drain into the beaker, but I'll go ahead and set my known kind of here as well, just so it holds it. Okay, all right, so the gravity filtration apparatus is set up. Next we're going to add some of the boiling water, so about 2 mils of the boiling hot water into the test tube containing the precipitates. So I'm just going to pull some out of here, and that'll be fine. So roughly 2 mils or so. Nice toasty water. And I'll do that to the other one as well. Might have been a little bit more than 2 mils, but that's okay. All right, whew, nice and toasty. All right, so I've got the boiling water in there, and then I'm going to basically take these test tubes and I'm going to place them into the beakers. All right, and so placing these into the beakers, I'm going to let these actually kind of sit and heat for 5 minutes. All right, oops, and while this is going for 5 minutes, I'll periodically stir each of these with a stirring rod to get that solid to dissolve. Okay, so there I stirred the unknown, and I'll go back and do the known kind of off camera. And after the 5-minute heating, basically this heating step is going to be one where the lead is going to dissolve, but the silver and mercury precipitates, those are going to stay behind. Those are going to stay put. Okay, so we'll be back after kind of this 5-minute period has passed to take a look at what we have then. All right. All right, so we're at the end of the kind of the heating period, the 5-minute heating period. So again, this is going to dissolve the lead ions, the lead chloride, but the silver and mercury chloride salts are going to stay put. Okay, and so now I want to basically rinse my filter paper with 4 mils of the leftover hot water. All right. So I'm going to do that. I'm going to take my waste beaker and just kind of put that underneath here. All right, so I've got my 4 mils of hot water, roughly 2 good healthy squirts of hot water in there. All right, and I'll do the same with the other one. All right, so my filter papers have been rinsed with the hot water. All right, and now I'm going to take and transfer the contents of the test tubes into the hot filter paper. All right, now the solids that are going to be present are going to contain the silver and mercury. The liquid is going to contain the lead chloride that's been dissolved. So I'm going to take a new clean test tube and just kind of put that up under my funnel here. Move the timer out of the way. All right. So this is going to collect that liquid, which has the lead in it. All right. All right. So let's see here. All right. I think we're good here. All right, so I've got my known that I just pulled out of the hot water bath. All right, and so I'm going to transfer that over into my filter paper and collect that liquid. Okay, and then the solid is going to be, there is going to be a little bit of kind of residue kind of here in the test tube. All right, I'm going to take let's see. I'm going to take a little bit more of the hot water, and I'm going to try to get some more of this solid transferred over. All right. So I'll kind of swish it around here and do a kind of a quick transfer there. Okay. All right. So still a little bit of solid left, but that's okay. It's not too bad. Most of it's been transferred. All right. So for the unknown, go ahead and turn this off for now. For the unknown, I'll go ahead and kind of swish it around a little bit. Test tubes in there. So I'm going to transfer that over and collect that liquid. So the solid, again, is going to get caught by the filter paper, that white solid that's left, and then the liquid is going to be kind of transferred down to the test tube. Okay? All right. So now we've got in these 2 test tubes the 2 solutions. And if there is lead present, well, we know there's lead present over here in the group 1 known, but if there's lead present in the unknown number 5, then we should see that. Now, if we let this cool on its own, sometimes we see precipitation occur. It's still pretty toasty, but one of the ways in which we can kind of speed things up, and sometimes it will precipitate on its own, sometimes it won't. I'm not seeing it quite yet. But what we can also do is kind of, as the procedure said in step 6, we can add in a couple drops of the potassium chromate. All right, and so this is a potassium chromate solution. And if we add in a couple drops of potassium chromate, The potassium chromate is, of course, soluble. All right, so group 1 compound is going to be soluble. If we add in the potassium chromate, the chromate ion is going to react with the lead and form an insoluble lead to chromate. All right, so I'm going to add in a couple drops of this. I don't see the cloudiness yet, but again, it's a little warm yet, so we'll see. So I'll add in a couple drops of the chromate, 1, 2, there, and oh yeah. So notice we have a bright yellow precipitate there, indicating clearly that there is lead present in the group 1 known solution. Okay, so the group 1 known definitely has some lead present. Let's take a look and do the same thing with the unknown number 5. So if we add in a couple drops, 1, 2 of the lead or of the potassium chromate, again, notice that same exact color for the known and the unknown. All right. So very clearly, you know, we have a similar type of appearance for the group 1 known and unknown. So obviously, unknown number 5 does indeed have some lead present in that particular unknown. Okay. All right, so we have taken care of the liquid where the lead has been dissolved in that liquid. Clearly, lead is present in both. The next thing we're going to do is take and look at the residue left in the filter paper. All right, so now what we're going to do is we're going to wash the precipitate with 2 5 ml portions of the distilled water. All right, so I'm going to go ahead and get another waste beaker for each of these, and I'm going to wash this with probably 2 5 ml portions of distilled water. All right, so kind of wash everything down. So there's probably about 2.5 or so mils. There's another 2.5 mils. And I'll do the same thing over here. Hopefully hit the waste beaker. Well, maybe not. 1, 2. All right, so that's 5 mils of water in both of them. So let's do that again. So 1 and 2. So we're washing with the hot water because we want to try to get rid of any of the leftover lead that might have been still present. All right, so that's now going to go into our waste beaker down at the bottom. Okay, the next thing then that we're going to do is we're going to get rid of the waste, and then 2 more test tubes. So we're going to get rid of the waste, and we're going to basically add in some reagents into our beakers. All right, so we've got rid of the waste here. So we're going to pause a second. Thank you. All right, so we're going to put 2 new test tubes up under here. Here's number 1 and number 2. Okay, so now we're set for that. We've washed our precipitate. We've discarded the filtrate, the liquid that was left over. Now what we're going to do is we're going to add in 30 drops of ammonia. All right, and so the 30 drops of ammonia, 6 molar ammonia, is going to cause the silver chloride to dissolve, but we're going to leave behind a mercury salt, a mercury residue on the filter paper if there is mercury indeed present. All right, so we want 30 drops of ammonia. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, almost 1 whole dropper full, 28, 29, 30. All right, and then we do the same thing over here. So 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and one more just for fun. All right, so we've added in the ammonia. The ammonia is kind of passing through. So again, that should dissolve the silver. The silver should go down into that test tube. And then in the filter paper itself, we should have basically that insoluble mercury salt. So I'm going to pull the silver solutions out and off to the side here. And let's take a look at the filter paper. All right. So if we take a look at the group 1 filter paper, notice that we have kind of a very black residue in the very middle of that filter paper. All right. That black residue does indicate that there is mercury present in the group 1 known, which again is what we would absolutely expect. Now, over here, if we look at unknown number 5, notice unknown number 5 is completely different, right? And so we don't see that black residue, all right? And so the absence of that same black residue here in unknown number 5 indicates that there is really no mercury present in number 5, but there is mercury present in unknown number 1, or in the group 1 known, which again we knew had all of those present in it. Okay, all right, cool. So that, I wonder if I can pop these up here. There we go. We'll see. All right, so that gives us kind of that indication of the, that's not safe. Indication of the mercury that's present. The last thing we're going to do then is to check for the presence of the silver. Okay, and so for silver, here we're going to add in 6 molar nitric acid. All right, so with 6 molar nitric acid, if we add in a 6 molar nitric acid, we should get a white precipitate. All right. Now, right now, this solution is basic, all right? And so what we want to do is, because we've added ammonia, this is a basic solution, we want to turn this solution to completely acidic, okay? And so I'm going to just add in quite a bit of 6 molar nitric acid. And when we do, and make it incredibly acidic, notice we have that bright white precipitate that's formed. Okay, now the procedure says to test with litmus paper. I've added in so much nitric acid that I'm going to go ahead and skip that step. Okay, but if we tested this with litmus paper, it would indicate that it's acidic. Okay, so very clearly we have silver present in this group 1 knowns. Now if we do the same thing with the unknown, all right, again, add a big healthy squirt of nitric acid in there. All right, so notice we see again that same precipitate. All right, so